if you had a circle, let's draw a circle, with radius r and an angle theta, and one note here, guys, make sure you understand this formula only works if theta is measured in radians. Okay. We call the arc length S. It's like this curved distance. I like to say if there was a little ant traveling on the edge of a piece of pizza, isn't a piece of pizza like a sector of a circle? A round pizza? There was a little ant traveling around the edge of that pizza. You can't really measure it because it's not straight, right? It's part of a circumference. So this is the formula that gives us the length of that curved piece S. Okay, so here's how it works. If the angle is already in radians, it's awesome. We just use theta times r. Is it theta already in radians here? Let's find the arc length. S equals theta times r. So we write 5 pi 6 times 4. Cool, we can do this. That is 20 pi over 6, which is reduce it. 10 pi over 3, and the units are going to be the same as the units on the radius. Okay? Otherwise, you have to get them to be the same. Uh-oh, what's the issue in B? There's a little problem here. It's in degrees, but it's really not a problem because we can convert it, okay? So here's what we're going to do. S equals, here's my theta. I'm going to do 125, but I need to convert it. So what do I multiply 125 by? Good. Pi over 180. So there's my theta. And times the radius would be times 1.5. So it says here we're going to express our answer in terms of pi. Let's do at least the top and see if we can reduce it. 125 times 1.5. Pi. It's not nice, isn't it? Does 1.5 go into 180? It does, because 3 goes into 180, right? Yeah, let's do that. It goes in 120 times. Okay. So 1.5 goes into itself once, into 180, 120, so then I get 125 over 120. What do I know for sure those are both divisible by? 5. Good. What's 125 divided by 5? What is that? Yeah. How about 120? No. What did I say? Divisible by 5? 25. This one's 25. And this one's 26. What's that?
25 pi over 24.
Hold on. Hold our horses. Oh. Yeah. There was my little borrowing mistake. Okay, so this should be 25 pi over 24. Millimeters would be the units on that. Okay. So arc lengths, sometimes you'll be asked to solve for different things, but it's just S equals theta times R. It's just division, multiplication. Those are pretty basic algebra concepts, right? If I gave you, if I said solve for R, look where my finger is. If I said solve for R, what would you do? Divide by theta. If I said solve for theta, you would divide by R. Okay, good. Okay, last thing, kind of having to do with the unit conversion. Remember the unit conversion we were just working on? Except unit conversion is just like linear speed to linear speed. This is saying, what if I tell you how fast something is revolving and I ask you to figure out how fast it's going? This is actually, have you ever seen the revolutions per minute thing in your car? Okay. What it's telling you is how fast your tires are spinning around. Okay. And actually, there's a relationship between that and your miles per hour. Miles per hour is your linear speed. So angular speed, how fast something is spinning. Linear speed, how fast something is traveling in one direction. I'm going to change up example 4 a little bit, okay? First of all, half the people in first hour didn't even know what a turntable was. Do you guys know what a turntable is? What does it do, Hatcher? Records! Spins records around. I used to listen to records when I was little, with the little book and the beep and then you turn the page. Did you ever do that with like a different, not with a CD? Aw, you missed out. That's like how I learned how to read. And they'd read it with you and then beep, and then you turn the page. She's just making it up to make me feel better. That's okay. Okay. All right. So, let's say I told you a turntable rotates at 50 revolutions per minute, and I'm going to have you actually do this. We're gonna find some linear speed. I'm going to tell you the turntable has a radius of 20 centimeters. What I want to find is its speed in centimeters per second. Okay. At the beginning of class today, I had you write down what one revolution equals. Do you remember what I had you write? One circumference. Okay, so here's what I'm going to start with in problems like this. I am going to put the 50 revolutions down here. And I need the word revolution to cancel. So on the bottom of a fraction, I'm going to write one revolution. And on the top of the fraction, I'm going to write what the circumference is. Because aren't those equivalent things? So according to what I said, what should I write on the top then? If the radius is 20. 2 times 20 times pi, so 40 pi centimeters. That would be the circumference. What words are going to be able to cancel then? Revolution. Okay, do you see how then I'm going to have it in centimeters, which is what I want. Okay, this was actually 50 revolutions per minute, right? So this was actually over per minute. Now, this is not something new. How would I get that minutes on the bottom to be seconds on the bottom? What goes on top, what goes on bottom? 1 minute goes on the top, 60 seconds goes on the bottom. because I want the words minutes to cancel, so I have to put one on top, one on bottom. All right, let's do it. So 104.7 centimeters per second. Okay. Let me tell you what that means. If I put a little dot on the outside of a record, do you guys even know what a record looks like? Okay, good. If you put a little dot and then you started the record player, that little dot would travel 104.7 centimeters in 1 second. Is that kind of fast? Yeah, but a centimeter isn't all that far of a distance. Okay. Now you could still do the same thing like with a person riding a bike. If I figured there's revolutions per second, you could figure out like their speed in miles per hour and stuff like that. So I might ask you to do that. Alrighty.